2,955?
Yeah.
And how many million are we going to do that by?
5.
5 million. All right. Hey folks, welcome, and welcome out there. Specialized segments, you got it. Mathline, you've got it. I'm Ernie Roberts. I am your host for this afternoon's session. We're so glad you tuned in. And some of you maybe are tuning in by Facebook. Some of you may be using our YouTube. Some of you may be going Mathline online. All those good things. We're so glad to have you with us. And you know, also you can check out us on Passport. And of course, hopefully you're viewing us right now live on TV. But you know what? We have a great show coming for you. We're doing test prep. So specialized segments time, we don't get to call in, but we do give you some information, some problems. We suggest you get a pencil, paper, maybe a calculator, and let's work some problems out together. And they're going to look kind of fun and fancy today, but all in the name of test prep. So let's see where we're going on our topic for today. We are going in search of hidden triangles. We're going to be looking at some pictures and discovering, ooh, sometimes there are triangles there when we really didn't think there were, all right, or when we really need them, how to look for them. So let's go back through our high points here that we've gone through. Those you've been tuned in the last few days or to the series prior to this, you know that we have some theorems and corollaries that we've been running through. We call them rules, basically governing our triangle work, all right? We have the blockbuster, which was the fact that 180 degrees in a triangle, that's the Triangle Sum Theorem. Always the inside angles, the interior angles of a triangle will add up to 180 degrees. Now the exterior angle was basically about the fact that an exterior angle formed with one of the angles, of the triangle would be equal to the sum of the remote interior angles. You say, what? We'll look at that one with a picture here in just a moment. All right, we'll go back and review that one a little more explicitly, all right? And the right triangle corollary, simply, if you have a right triangle, the two angles that are not the right angles, which we're going to be acute, by the way, will add up to 90 degrees. Now, the whole triangle adds up to 180, but you've already used up 90, so therefore, you've got those two acute angles that are complementary, or they do add up to 90 degrees. And last but not least, don't forget about parallel lines and those relationships. You say, what do you mean relationships? How about the angles? Corresponding angles, which will be congruent. Alternate interior angles, which would be congruent. Alternate exterior angles. And there are those same side interior and same side exterior, which are supplementary, but we'll see what we come across in these pictures, all right? But just remember, we'll hit those, and I'll remind you, hey, these are parallels. Guess what? We can use maybe corresponding, maybe alternate interior, maybe alternate exterior, and have some congruent pairs, which, by the way, help us find degree measures really, really nicely. So let's see where we're going to go, all right? We've got the background here. I said something about, possibly a new problem, a new, new figure. How about it? Let's take a look at it. Now, right off the bat, I always like to ask my students when we see this figure, how many triangles do you see? And most of them will say, 1, 2, 3. There are 3 triangles. Well, for the most part, that's true. For the most part, that's true. There are 3, but there are actually 2 more. So let's go and pick up big ones. See where the big ones is? That would be like angle 1, 2, and 3 make one nice angle there. And then down here at angle 4. So you see how it's crossing? 1 and 2. Those two triangles go together. All right, it's just like they got glued together. If you saw it on the left-hand side, you got it on the right-hand side also. These 2 triangles basically glue together to make one nice big triangle also. So when we're looking at these, many times we fail to see the big picture, all right? And that's why I say this in search of hidden triangles, because there you go, those bigger ones there. And the whole figure, well, it's some sort of strange looking thing, isn't it? Looks like a not convex pentagon if you were to pick from here, here, here. There's 2 sides, 3, 4, 5 sides, but you've got that convex, not convex situation, right? We call it sometimes concave, but that would be an example of a concave pentagon. If you look at the whole picture, we're going to be talking about little triangles. So let's take a look and see what we've got. Information, oh my goodness, we've got a lot of information. First of all, CA perpendicular. That's what this little guy up there is telling. By the way, folks, don't just look at a picture and say, I bet those are right angles. They may or may not be, but in this case, because it says perpendicular, we do have a right angle there. That also tells me 2 and 3 are going to add up to 90 degrees because they are adjacent. They're inside that right angle, and that's another little concept to think about. Ooh, adding 2 angles together to get the angle if they're adjacent, the big angle, and you get 2 plus 3, which will give you CAB in terms of degrees and measure. So there's one thing, by the way, that's 90. Take a look on the other side. We got DB and AB. Oh, yes. And they're going to also come out in that manner, which is really sweet because if I know one of these angles, guess what? I got another because I know they're adding up to 90. They're going to add up to 90. Now, let's check something else here. Remember I said think big, think big? What numbers do we know? We know angle 1 is 40 degrees. Let's go ahead and mark the figure. By the way, you all feel welcome to draw this thing out at home or see if you can punch around the numbers and stuff there. And also we gave you number 8 over here. All right, we're going to say it's coming in at 70 degrees. And you say, well, Ernie, why is that important? Oh, it's very important because now we're thinking, remember I said think big triangles. Think big triangles here. We have a lot of good things happening. 70, and what's this little guy down here? This angle 3, they make a nice right triangle, you see. Remember what we said about those? The acute angles, which would be D, and angle 3, complementary. So they're going to add up to 90 degrees. See that? Big picture. There we go. Oh, if it works for that one side, it's going to work on the other side, isn't it? Let's see here. What are we going to have? Looks like we have 40 degrees here, and we're going to kick that right around here, and look at 4. 4 and 40 are going to add up to 90. So there we go. We've got some numbers starting to fill in. So since we got angle 1, and we hopefully will figure out angle 2 in just a minute because, you know, if we can get 3, we can get to 2. How about that? Get to 3, get to 2. So let's see what's happening. We do have, as we said, a right triangle. So angle 8 up here is an acute angle. 70, remember, all the way down here at angle 3, put in 20 degrees. Ah, that gets us started. Now, what else do we know? We do know that that is, you got it, complementary because it's basically 2 angles that are adjacent inside a right angle. So we know those angles are complementary. And we're also going to put 70 degrees right there. Well, that worked out pretty good because as we start looking here, remember, now we can look at the little triangles, at least on this one. We can figure out what angle 6 is going to give us. And it looks like it's going to be equal to, the measure is going to be how much? Well, how many degrees we got here? 40 and 70 gives us what, 110? Then we subtract it from 180. And we got another 70 degrees here. Well, that just turned out to be a nice little sweet isosceles moment, didn't it? Well, we may have another of those. We never can tell, right? Okay, now let's play some more here. Did we have anything? We don't know anything going on. Oh, we do. We do. What about angle 4, since we're jumping all over the place, all right? Some of you say, Ernie, just go in order? That'd probably be a good idea. Let's talk about it here. 40 and something give us 90 degrees. So let's go with 50 degrees right there, which tells me this angle 7 also is going to rank out at 40 degrees. Pretty good. Why? Because they are complementary also, making, how about it? Making 90 degrees happen there. One more moment. Looks like we've got another little moment happening here. Same, oh, this looks like these triangles. They aren't congruent, but they have the same shape because all the degrees. They would be similar. But let's see what's going to happen. That's going to be 70 degrees. And you know another reason why it's 70 degrees? You've got vertical angles sliding through here. Now, all of a sudden you're saying, man, I kind of feel a little overwhelmed. Well, there are lots of ways to get through this problem once you start noticing that. Once you start looking at the big picture, then you've got all these little triangles that are working beautifully. Oh, while we're at it, angle 5, we don't really need to go through a whole triangle because what do we know? We know that this is going to give us 110 degrees right there. So that is your measurement there. How do I know that? Linear pair, supplementary angles, straight line, straight angle, all those things. However you want to say that makes a ring to you. So vertical angles, linear pairs. Now, I said something about parallel lines in our last picture over there, where I said this is one of the things we might want to remember. Now, I'm going to say something. Are these lines, AC and DB, are they running parallel? You say, well, I don't know. Yes, you do. Yes, you do. First of all, you start looking and saying, ooh, 40 and 40, the way they worked out, those are nice alternate interior angles. See the zig and the zag or the N? That is going to allow us to get parallel lines. Or if you didn't see the 40 and 40, how about the 70 and 70? They're also alternate interior angles. See that Z that's kind of on its side? Looks more like an N this time, or a backwards N, depending on how you're looking at it, all right? So how do we determine that? Could we have done it without getting those degrees? We certainly could, because we had the perpendicular, and remember, in a plane, if two lines are perpendicular to the same line or to a third line, or in this case, segment, they're going to be parallel to each other. So you got the parallels working, you had the right angles working. So again, in this picture, lots of things going on. Lots of things going on. And once you see the big triangles, this thing just falls apart. It really is easy. Now, we're going to get some practice on that a little bit in just a minute, all right? So you keep this figure in mind. If you're at home, you can go ahead and draw it again. We're going to get to it in just a second, but let's look for another pair of hidden triangles here. And in this one, we've got, wow, crazy things all over the place here. But I notice I threw in some right angles. So we're going back to that corollary business, all right, with the right triangles, because, you know, right triangles are such good friends. If we've got them going, they're easy to figure out. If we know one more thing, we can find out other things. So let's look at it. Here's a big right triangle. Here's a big right triangle. While we're at it, there's a big right triangle. And there's a big, oh my goodness. So there you see four big right triangles that maybe weren't popping in your mind at first. We have a huge triangle. Equilateral? Nah, not quite. That's 62 degrees, so you know it can't be equilateral. But we've got some good things happening here. Oh, little right triangles. We put a little mark right there. I'm going to put one right over there. I'm seeing 6 right triangles in this picture. And there's another triangle. And then the big triangle. So lots of triangles hanging out there. What, we got 8 total? And some of you say, what about that one? That's not, that's a quadrilateral. 1, 2, 3, 4 sides. So thinking big, look at the whole big picture. And I'm going to tell you something. Finding the angles are going to be pretty easy on this one. So let's take a look and see how we're going to go. We have 62 degrees in this right triangle right here. Everybody with me? You got it? So what does that leave us? That means we've got 90 plus something for x. X is going to be pretty easy to find. The measure of angle x is going to equal, well, what do you think? How much do we have? That's always a good question. Thinking it? 90 minus 62, I'm getting 28. 28 degrees. We good? We good so far? Now, what about our lovely old angle y up here? Well, you know, now we got x going here. This makes y a lot easier to figure out because we have a full angle. We were only getting a partial angle down there. Now we got 53 degrees and we got a question mark. We got 90. No question mark there, it's a box. But what's going on up here with y is going to be, basically, it's going to be 90 minus, what, 53 will equal your y in degrees, all right? So let's see what that's going to give us. Pretty straightforward. It looks like 37 is what our magic number is there. So if we put 37 for y, so we'll put a 37 right up there. And we've got what we're looking for, all right? 37 there, we got 28 here, and then we got this 25, which is something totally different there. If you had to find anything else, guess what? This guy up here is going to be 28. How about it? Can we play in the middle? Oh, certainly we can. We got 28 here. I just want to go a little further because you know what? On a test prep question like this, we've got so many possible options they could ask you to find. If you saw this picture on an ACT or an SAT and you had just those two numbers that we were given, that 62 and yes, 25, you can find any angle you want, and this because of the power of the right triangle business there. By the way, this one is not going to be, this big triangle, obviously we said was not, not equilateral. It had a temptation to maybe look that way. But you got a 53-degree angle here. Looks like we have 65 up there and 62. And by the way, all of those add up to 180. So there's another element you can play with here. You got your right angle here. How about it? Let's go with, how about it? 62 right there in the middle. 62 here. Play the vertical angle moment. I like the vertical angle moment. We got 18 degrees there. And by the way, all those do add up to 180, exactly. And then we've got 118 degrees here, which you say, Ernie, that doesn't add up to 180. No, because it's not a triangle, remember? It's a quadrilateral, so it should add up to 360. So we got all the degrees of any angle you want in there. X and Y were pretty easy, weren't they? Getting to the other part, it's a lot of fun. So that's what we want to do here, is be able to find any angles in any direction. The problem sets you up to go, all right? So let's take a look at one more here. And this one's actually got a triangle waiting for you. Remember I mentioned the son of Blockbuster. You didn't say the son of Blockbuster, I said the exterior angle theorem, right? So what happens with that is, remember this angle out here is equal to the sum of those remote interior angles. We don't want to forget that. Don't forget that, because that's another option here. Here you've got a triangle, but here's a little hidden help if you need it. And my friends, you need it because we don't know what this angle is. If this angle were given to us, we could just use the 380 degrees in a triangle, 3 angles adding up, and we'd be good. Unfortunately, we don't have that luxury. So let's play the game. This thing out here, big angle, 70x minus 2 is equal to the sum of these remote interior angles. Now, some of you getting a little panicky over there. You're using double-digit x's. Well, that's all right. It's okay. We're going to be all right. Just trust me. You want to trust me, don't you? And we're going to add that to, looks like 18x plus 4. Now, it says solve for the angle measurements. Folks, you got to find x before you can get to the angles here, all right? So in this test prep type exercise, we're going to look for ways that sometimes you got to think a little bit beyond it. Got to use a little algebra, and you've also got to use the, we said, the exterior angle theorem of your geometry here for a triangle. So let's see where it's going. 70x minus 2 is going nowhere. But these two guys are going to add up. That 46 and 18, believe it's going to give us 64. 64x. You can hit that calculator if you want to. Looks like over here we have a plus 10. How'd I get that? Remember, 6 and 4, like terms. Put them together. Now, time to get x by itself. This works out really nice. We're going to take 64x, and all of a sudden my numbers are reducing quite nicely. I now have 6x minus 2 equals, what is that, 64x there? Yeah, we got 10. Oh, that's so much nicer to work with. Add your 2, both sides. Remember, that's a minus 2, so you got to add 2 to both sides. Addition property of equality working for you. And you got 6x equaling to 12. I like it because x is going to come out even. It's going to come sweet. And actually a very small number. X is 2. Now, what are my angles? Put a 2 right there. And multiply. 70 times 2. Subtract your 2. I believe it's going to be 138. Because 70 times is what, 140? Take away 2. Ta-da! 138. Now, over here on these little guys, yeah, it might look like it could be tough, but put a 2 in there. 18 times 2, double 18. That's all we're doing is doubling things and adding. So let's try that again. Double 18 is 36. And add 4. Oh, that's 40. So that's nice. That's 40 degrees. And then last but not least, how about our little guy up here? We'll put a 2 in its place. 92. Wow. Plus 6. That's 98. And friends, look what happens. You take those two, 98, 40, you get 138. Now, you say, Ernie, what if they'd ask for this angle measure? And sometimes they will. After you've found all your little x business, you say, what are we going to do? We're going to subtract 138 from 180, and we have 42 degrees left. Now, if you'll notice, these little guys, do they all add up to what we want? 140 plus 40, 180. Does the exterior angle theorem satisfy it? Yes. And is x equals 2 happy? Yes, yes, yes. We love that because it's a small number. It's easy to substitute and work out. But also, I'll give you a little hint. They're not out to get you through a lot of difficult algebra, all right, on a test. But you got to remember the rules to get you set up, and usually things will fall out fairly decent. You might have a 2.5 or something like that. But if you start getting 2 and 1/7 for something like this, and you got to find the angle measurements, and especially if no fractions are given in the problem. In other words, they should come out pretty nice, all right? So take that to the bank and keep that in mind. If it starts coming out messy, you might want to fix it. Hey, let's go back to our first figure one more time here, all right? Let's take a look at it here. This time, I threw you the parallels this time. Wasn't that nice of me? I think it was very nice of me. Everybody's going like, yeah, nod, yeah. Now, what are we going to say about this? We got angle 8 once again, this angle up here, pesky angle up here at, 65 degrees. Now, I gave a perpendicular. Where's that perpendicular? It's over here on the left-hand side. So some of you go like, we got a right triangle. Well, we do. And we got angle 1 up here this time, cashing in at 42 degrees. That's what's nice. So that, folks, gives me a chance at angle 4. Remember what we said about those two angles? They're in, remember, think big. Big right triangle. Big right triangle. There you go. And what are we going to do? They're complementary. Means they add up to 90. The 42 and 4, so we're going to put a 48 in there this time, 48 degrees. Now, I know some of you are thinking, Ernie, we don't know about that perpendicular over there. We had right triangles on both sides, that earlier problem that we did. You know you're right. So what do? Is it a right triangle? Is DAB a right triangle? Big question here. In other words, is angle DBA, notice I didn't say angle B because there's 3 angles down there, but is that big angle a right angle? And you know what? It is, because the perpendicular here and the parallels, that means that has to be perpendicular also. In other words, we got a right angle. So if this, my friends, is 48, then we got 42. Now I know what someone else is out there thinking. Ernie, they're parallel, alternate interior angles, 1 and 7, congruent. Exactly, because if the lines are parallel, each pair of alternate interior angles will be congruent. So that's another way out of the jam. It's another way to get to the final answer. So you would have had 42, you got 48 from the right triangle over there. Let's kick the rest of it through here. How about it? We got 65 waiting here, so go with 25 for angle 3. Why not? They're complementary, right? See, we now have a big right triangle. And while we're at it, you want to go for an angle 2? What's angle 2 matching up with? Looks like we've got another zig and zag. We got 65 here. Hey, 65, 25 makes a right angle. That's such a beauty of geometry, my friends. All these numbers start clicking together. What looks like a random start on the page here, you start putting numbers in there and things start coming together. That's what math is so fun. That's why I love it. Do you love it? We all love it. Now, look again. We pulled out one of those because of the parallel lines. It looks like we got another pair of similar triangles. What we need to do, though, is figure out how many degrees do we have at 6. All right? How many degrees do we have at 6? Whew. Looking. I have 107 between these two right here. Add 42 and 65. We're going to look at the small triangles now. Remember, there are 5 triangles in here. We're going to take these little guys now. And once again, back to that 107, subtract it. I believe we're going to have 73 for angle 6 this time. Do those add up to 180? Nod with me that they do. That means a vertical angle is going to send you right over here also. Make a 73. Angle 5 is the only one that's kind of left out of the party right now. Let's put it in. Looks like if we take 100 and, what did we say? 107? That's what we have, isn't it? You know why? Because 5's one of those exterior angles of that triangle. But also, we could have just subtracted from 180 and we'd be where we were going. And by the way, that is at 107 degrees. Pretty cool. Oh, by the way, do these add up to, what was that? That's 48 down there. Looks a little blubby. Add those together, 180 also. That, my friends, is power of the geometry. Power of those theorems. They work. And they're triangles, and they're basically glued together beautifully there, all right? So practice on those, all right? And we may come back and do some more of these during the regular show, during the season, all right, as time wears on us, and sometimes we have a few lulls in the main show. But we want to thank you for tuning in this afternoon, and this is test prep, whether it be end of course, whether it be college entrance exams, the SATs, the ACTs, we want you to feel comfortable with some of the basics in geometry. And the basics here are 180 degrees in a triangle. Remember I said we call it blockbuster? I call it blockbuster. Nobody else does, but I do, because it's probably the biggest thing other than the Pythagorean theorem that we do with triangles and we do in our geometry. It's a very important thing because without 180 degrees in a triangle, you can't figure out what's going on in any other polygon, whether it be a quadrilateral, pentagon, hexagon, all those things. So we're going to look at those one day too sometime in this prep session, we hope. I think we'll be able to pull it out. Not necessarily tomorrow, not necessarily, but you'll be able to find us, you know where, Mathline on YouTube. And also, you can still keep with us on Facebook. We'll keep you posted on what's going to be topic of the day as you're working. But thanks for tuning in. We're glad to have you with us this afternoon, and we will be back again, ready to see you again next time.